All right, I have a math question. It's not in a histogram form, so sorry, Nate.
All right, I can make it work though. I'll make a histogram on this.
2 times a minus 3 plus 4b minus 2 times a minus b minus 3 plus 5. Can you help me simplify the expression?
Yes, I can. Thank you for asking.
Thank you.
So first of all, since we're talking about why we learn how to do things, like why do we learn how to simplify? So I always like to use this example with kind of money, like why bother simplifying this? Doesn't it mean the same thing? That's what we always talk about. You simplify an expression, it has the exact same value, the same relationship, the same meaning as when it was like kind of a mess. And I always like kind of think about money, like if you have a bunch of bills, you got like a dollar bill, maybe you got a $5 bill, you got a I was going to say a $25 bill, and then I was like, that's not a real thing.
Doesn't exist.
Yeah, and then you got a couple quarters. That's what a quarter looks like. It looks like that with 25 cents on it. And then maybe you got like 2 pennies. So if you had all this money in your pocket and somebody asked you how much money you have, I don't know why somebody would ask how much money you have, but you could definitely say, oh, I have $20 plus $5 plus $1 plus 25 cents times 2 plus 1 cent times 2. But that would not make a lot of sense. So a lot of times in math, we kind of think about it the same way. I like to think of math as this language that explains these relationships, like numerical relationships. And what we try to do is come up with a way that if I tell you something, maybe some expression, that whoever I'm speaking with and communicating with will understand it quickly. Like, again, if I said I have $20 and $5 and $1 and then all this change, you can probably figure it out, but you might have to write it down. You might have to do a bunch of mental math and figure it out, when it'd be much easier for me to say I have $26.52. And it is the exact same thing with math when we simplify. I could say I have some relationship that's represented by all of this mess, but if I were a scientist or something and I had some relationship that I wanted to explain to Sam, and I explained all of this data like without simplifying it, he would either one, just be like, what are you talking about? Because that's just a lot of stuff. Or two, he would have to sit down and write it all down and figure it out himself. So we try to think of this as a more concise and deliberate way of communicating different expressions in math. So that said, this all comes back down to our favorite Pemdas, and I can't remember, something about pink elephants may dance. Oh, pink elephants may dance and sing.
Nice.
That's how great these are. I didn't think I remembered it.
Please
I
excuse
did.
my dear Aunt Sally.
Yeah. All right, so kind of go through PEMDAS, and we've done this quite a bit this season, but that's good because this is a very crucial part of math. Like, if you're going to move on next year, you have to have this down cold. Otherwise, everything's going to be hard. So the first thing we do is we look at our P. If you remember, oh, you know what? I don't have enough space up here to write it all out, so I'm going to write it. I'm going to move this. I'm going to say PEMDAS. And we're going to start with the letter P, and that stands for parentheses. So all we're doing is we're trying to simplify everything inside of the parentheses. So what I like to do is I just look at all my parentheses and think, can I do anything with this? Can I write this in a simpler way? And you can't see that, so see if I got another color here. Nope, only got the two worst colors to highlight these letters with. Okay, that's visible. All right, so we look at this and we cannot simplify because A and the number 3, these are totally different types of terms. So we're going to leave it alone. And we come here, still can't do anything with this because we have an A, we have a B, and then we have the number -3. Again, remember that variables represent numbers, but we can't know what numbers those are, so we can't just chunk them together or combine them. So the first part's easy. We just highlight a couple things and then say we're not going to do it. Exponents, again, kind of looking through here. There are no exponents, so we're going to move on past that. And now we get to something we can actually do, multiplication. Now, remember when you're multiplying, if I'm multiplying a number or whatever it is, it could be a variable also. If I'm multiplying it by this, a minus 3, we're not just multiplying it by a, and we're not just multiplying it by -3. We have to keep in mind we are multiplying it by both. And I won't get too into like describing that at this point. But this is where we use the distributive property. So we're going to distribute wherever we can. And so I'm going to take this 2 and I'm going to say, look, I need to multiply that by a. So 2 times a is 2a. And then we need to take that 2 and multiply it by -3. And don't forget this negative here. It's really important. And we're going to get 2a minus 3. And we kind of just keep going down. If there's nothing to multiply, I just keep copying stuff. And you will get better at not having to do every single step. But if you're just learning this, I would suggest write it all down for 2 reasons. 1, it kind of reduces your chance of a mistake. And 2, it just kind of helps you process everything as you go. When you try to go too fast, you're not usually thinking things through very well, and it's easy to make mistakes. So for this next part, -2, we're going to distribute. And we have to, you see I highlighted the negative also, because we need to multiply that as well. So -2 times a, we're going to have -2a. Then I'm distributing -2 times -b. Watch out for that. That's positive 2b. So negative times a negative is a positive. And then -2 times -3, positive 6, and then plus 5.
2 to 3 is -6, isn't it?
Oh, I made a little mistake here. So right here, 2 times, right, that's 2 times -3 should be -6. All right, I was just doing that to see if our producer was paying attention.
That's a common one too, though.
Yeah.
It really is. It happens
Yeah,
more often than
especially,
you'd think.
yeah, the more you rush through it and the more you're kind of on autopilot, like we do these all the time, so sometimes I'm not processing things always, the more likely you are to kind of make these little mistakes. All right. And then we have another easy mistake, or not easy mistake, easy step, division. We don't have any division, so we're going to move on into our adding and subtracting. All right.
So, also should be pointed out that multiplication, division go left to right.
Oh, good point. Yeah.
So if we did have any division in there, it would go in the same step as multiplication. And I just like to point that out because it's a lot of times it's taught incorrectly. To where it's multiplication first and then division, but they go together. And that's, if you've ever seen on Facebook the common question, you know, where they throw a little math problem on there and then like people fight over the answer, it's because of that. It's oftentimes taught incorrectly.
Yeah, and a quick example to show that those aren't the same thing. Like if I did 2 times 3 divided by 4, actually that's not a good example. Let's do in the other order, 2 divided by 3 times 4. If you're thinking about doing, if you just are focused on doing multiplication first and not thinking about doing left to right, like Becca said, then what you would do is you would say that this is equal to 2 divided by 12, doing that multiplication first.
Right.
But really, it should be 2 divided by 3 and then times 4, which becomes 8 over 3. So much different answer. So yeah, make sure, and thanks for pointing that out, that you are thinking about the multiplication and division. The order is very important, whereas adding, subtracting in the end doesn't matter which way you do
that
it.
doesn't really matter, which I typically say left to right for those as well.
Just to be consistent.
Yeah, it doesn't usually make a difference.
All right, so last thing, we just really need to combine everything, and that's where our addition and subtraction come in. Things like this, I have a highlighter, and oftentimes if you are writing in pencil or heaven forbid you're writing in pen in a math class.
Oh gosh,
hope you're not doing
no,
that.
don't do that.
So we'll just pretend that's not even possible. So if you're writing in pencil, you don't have more than one color. You just have lead color. So
lead color.
I'm going to pretend like I have that too, because I think a lot of times as teachers I'm like, oh, do this in yellow, highlight this in orange, but you don't really have that option. So a strategy I like is to do different shapes or underlines. So I'm going to say, we underline all my A terms. Okay, I got an A here, I got an A here, and I kind of keep going through and I make sure I'm not missing anything. And then I combine them. This is subtraction, and like Becca mentioned, adding, subtracting doesn't matter what order you go in. So just for time, I do like the idea of always going left to right, but for time, I'm
Yeah,
gonna go.
no, you don't have to.
Yeah, so 2a minus 2a, that cancels out. That's 0, so I like to cross them out to make sure I didn't forget anything in the end. And then I go to the next term and I say, okay, I got a -6, and you might do like a box around it. And notice I'm including the sign to make sure that I don't forget the negative. And I kind of go through and I say, oh, I got a +6, and I'm just going to circle both of these, or square both of these. The -6 and the -6 cancel each other out, so I'm going to cross them out. And then I'm left with a +5. And you can kind of see that this kind of narrows it down so you don't make any mistakes and forget
anything.
Yeah, or double count something.
Right.
And then I use maybe a circle and another circle, and I say 4b plus 2b is 6b. And that's our
then
answer.
Stop
simplified.
there.
Stop there. You're not solving
Everyone
for B.
wants to keep going.
Yeah.
Just stop there.
They don't
They're
wanna
not
keep
like
going when you
terms.
want them
They
to keep
don't
going.
go away. You don't have to solve for anything. You're done.
Yeah, there's nothing to solve for because there is no equal sign.
Yep. That's very true.
Yeah.